You use one almost every single day. But have you ever wondered how a simple frying pan goes from a pile of raw metal to that perfect nonstick miracle in your kitchen? Today, we're taking you inside real factories across the world for an uncut, zero BS journey, how a pan is really made, from 0 to 100. Smash like right now if you've ever burned eggs in one of these. Let's go! Every single aluminum pan starts its life over 2 kilometers underground in giant bauxite mines in Australia, Guinea, or Brazil. That red dirt gets refined into alumina, then smelted at 950 degrees Celsius with massive electric currents to become pure aluminum. 1 ton of aluminum requires as much electricity as an average house uses in 4 years. But we're skipping straight to the factory gates because that's where the magic really begins. Step 1. The circle cut. Factories buy aluminum in gigantic coils. Some weigh 12 tons and are wider than a car. A machine called a blanking press, basically a 1,000-ton hydraulic punch, slams down 30 times a minute, cutting perfect circles called blanks. From 1 coil, you can make about 8,000 frying pan blanks. That's a lifetime supply for most of us. The blank is still flat and only 3 to 4 millimeters thick. How do we turn this pizza-shaped disc into a deep pan? Answer: deep drawing. This beast is the heart of the factory. The blank is heated to around 500 degrees Celsius, so it becomes soft like dough. Then a hydraulic ram with 2,000 tons of force pushes it into a die. In less than 2 seconds, the flat disc becomes a perfect pan shape. Most pans need 4 to 6 drawing stages, each one making it deeper and thicker at the base. After drawing, the edge is still jagged, so a trimming machine spins the pan at 3,000 RPM and a blade shaves it perfectly smooth. Now the pan is soft and weak, you could bend it with your hands, so it goes through heat treatment. Solution heat treatment at 530 degrees Celsius, quenched in water, then aged at 170 degrees Celsius for 8 to 12 hours. This makes the aluminum 3 to 4 times stronger without adding weight. High-end brands add an extra step, impact forging. Instead of pressing, they literally hammer the hot blank 15,000 times with a forging press, creating a denser, harder pan that will never warp. Almost no one talks about this, but the bottom of your pan is the most high-tech part. For induction cooktops to work, the pan needs a magnetic layer. Cheap pans get a thin stainless steel disc laser welded or brazed on. Premium pans use impact bonding, a 3 to 5 millimeter thick sandwich of stainless aluminum and magnetic steel pressed together with 5,000 tons of pressure. No glue, no welds, lasts forever. Then a diamond tip tool machines the bottom perfectly flat within 0.02 millimeters, thinner than a hair, so it never wobbles on glass cooktops. Now the controversial part, non-stick. Traditional PTFE process. The pan is sandblasted, sprayed with liquid ceramic or PTFE primer, baked at 400 degrees Celsius, hotter than your home oven ever goes. Then 2 or 3 more layers of mid-coat and top coat are sprayed with robotic arms doing perfect spirals, and a final cure at 420 degrees Celsius again. The coating is only 25 to 40 microns thick, thinner than a human hair. Yet premium versions survive metal utensils because of hard ceramic particles mixed in. New trend: ceramic nonstick made from silica, basically sand, sprayed the same way but marketed as PTFE free. Still not indestructible, but safer if you accidentally take it to 500 degrees, it won't release toxic fumes. Handles: cast stainless steel or heat-resistant silicone over metal. Riveted is best, screwed is cheaper. Premium brands use solid stainless rivets flush smooth inside, so no food gets stuck. Some brands weld the handle directly to the body. 0 screws, 0 movement, lifetime guarantee. Before packing, every single pan is tortured. Thickness measured with ultrasonic probes, non-stick scratched with a 9H pencil, thermal shock from 250 degrees C oven straight into cold water 50 times, AI cameras scan for defects, and finally a human eye checks for tiny scratches. Rejection rate in top factories, 8 to 12%. That's why good pans aren't cheap. 99% of factory scrap is recycled on site. Many brands now use 70 to 100% recycled aluminum. Same performance, 95% less energy than mining new bauxite. Packaging is recycled cardboard, often no plastic at all. So next time you flip an egg or sear a steak, remember, That pan in your hand traveled thousands of kilometers, survived 2,000 tons of pressure, 500-degree temperatures, diamond machining, and robotic quality checks, just to make your breakfast perfect. Which step blew your mind the most? Drop it in the comments. And if you want us to do knives, cast iron, or even carbon fiber pans next, smash that like button and we'll make it happen. Subscribe, turn on notifications, and we'll see you in the next factory. Peace out from the world of extreme manufacturing.